In this video, we're going to talk about describing the symmetry of an equation. So there are three types of symmetry. You can be symmetric with respect to the x-axis, symmetric with respect to the y-axis, and symmetric with respect to the origin. So let's start talking about being symmetric to the x-axis. To first start doing a problem, if we had x equals y squared minus 3, you should always start by graphing to get a rough idea of what the graph looks like. So this gives us a graph like this. So you can see it looks like this graph is a mirror image over this x-axis. So that would make us think that this is symmetric across the x-axis. But let's do an algebraic test to prove that. So to prove algebraically that you are symmetric to the x-axis, you replace y with a negative y, and you should produce an equivalent equation. So let's try this to our problem. We start with x equals y squared minus 3. If we replace with a negative y, we can see that we will get y squared minus 3 out when we simplify. And that is the same as our original equation. So that means that this is symmetric across the x-axis. So now if we do symmetric across the y-axis, we have an example of y equals x to the 4th minus 8x squared. And a rough sketch of this would show us something like this. So it looks like we have a mirror image across this y-axis. So to prove that, we must replace x with negative x and produce equivalent equation. So we have originally y equals x to the 4th minus 8x squared. So then we will have y negative x to the 4th minus 8 to the negative x squared. And when you simplify that, you just get x to the 4th minus 8x squared, which is the same as the original equation, which means this is symmetric across the y-axis. So lastly, we have symmetric across the origin. So, for example, for this one, would be y equals x cubed over 4. So a rough sketch of this will look like this. So for symmetry across with respect to the origin, you have to replace x with negative x and y with negative y and produce an equivalent equation. So when we do this, we have originally y equals x cubed over 4. So then we'd have negative y equals negative x cubed over 4, which simplifies to negative y equals negative x cubed over 4, because that negative x to the cube root stays negative. And you can see that if we would divide both sides by negative 1, we'd get that y equals x cubed over 4, which is the original equation. So this means this equation is symmetric across the origin. So you can see that when you want to prove it symmetric across the x-axis, you replace the y with the negative y. And then you do the opposite for y, you replace with x. So you replace with the axis you're not trying to prove. And then the origin, you replace both of them and solve.